Okay.
Welcome, Hernan.
Thank you. Thank you very much. Okay. The title of this presentation is The Problem of Chemical Law. This issue was widely discussed in philosophy of science, but maybe always taking physical law as reference patterns. From this perspective, universality and necessity was imposed as the main criteria to evaluate the legality of scientific statement. In this Congress, maybe the discussion was established in terms of whether philosophers are scientifically informed or whether scientists should be philosophically informed. I'm not so convinced that this is the relevant dichotomy, but what, at least at an epistemic discussion, what make a scientific law a law? That is, what scientific law function as a law. And the drawback with chemical law is, as we know, that they have a lot of exceptions. In this presentation, I will try to give, basis on the monistic conception of science, an explanation that maybe can explain why a chemical law are not so weird. Only to achieve this goal, the structure of the talk will be the following. First, I will review quickly different notions of law. Then I will introduce Proust's law, together with a case that it is present and exceptions to the law. Then I will overlook the different position that was given in the framework of philosophy of chemistry, particularly. And then I will try to explain why chemical law are not so different from physical law. Okay, let's go for the first items, and very quickly. We can say that if we adopt the Maxim's Quines without identity, there is no entity. Maybe the problem seems to die before its birth, because there is a lot of conflicting notions of law in philosophy of science. Indeed, the big notion of science was understood in terms of regularities or true regularities, a necessary relation between universals, axiom or theorems of systems, inference rules, nomological machine, and so on. In the other side, some feature was, it used to say that some feature are characteristics of scientific law, and in this sense, in philosophy of science, it is used to say that the law should be universal and restrictors. They should support some contrafactual statement. They should be different from accidental generalizations, and maybe they should be predictive and explanatory. But besides this, perhaps the most important feature that stands out is the universal character of the law. And in this sense, the problem with chemical law is that they are always presented with not insignificant cases of exceptions. For example, Proust's law, which states that any chemical component contains its element in a fixed ratio, that is, the mass of the element are always in the same ratio. An example of this maybe is there if we have 30 grams of nitrogen oxygen. There is a fixed ratio of 14 grams of nitrogen and 16 grams of oxygen, and in a sample of 19 grams of nitrogen oxygen, the ratio of nitrogen and oxygen is fixed at 7:12. But as it is well known too, this law does not apply strictly to Berthollet's, because in the non-stoichiometric solid, the mass does not have a definite proportion. In order to capture this degree of deviation, the equation of the Gustita, for example, is expressed like this, where X designate the degree of deviation. And in a crystallographic defect model, we can see the degree of deviation of iron in iron oxygen, because there is not an equidistant distance between the elements. Here we can vacuum, here we can atom more bigger, and so on. And the same go for polymerals, because any polymerals do not have a definite number of units in the chain. That's why maybe this is both cases that are presented as two exceptions to the law. Okay, what different philosophy of chemistry says about this issue? We can find in the bibliography two big positions. The first one that asserts that there's no chemical law at all, because they are not universal. And the second one that asserts that they are chemical law, but they are different type than physical law. I will try to explain, or I will try to give an answer that can be said that they are chemical law, and they are the same time than physical law. That's maybe my proposal. But first, let's see the first two options. With respect to the first one that asserts that there are no chemical law, perhaps the most famous position is the reductionism, according to which chemical law could be reduced from physical law. I'm not telling much more about that because it's an issue that we did discuss, but that's maybe the big point. But there are different and other strategies that try to explain why they are not law in chemistry, or there is not necessary that there should be some law in chemistry. I got like an eliminist from eliminativist point of view, from a probabilistic point of view. Schummer indeed asserts some kind of non-reductionist and eliminativist point of view. He says something like similar that Scerri just said before, that the notion of law is an obsolete notion that supposes some kind of universal metaphysics that cannot be compatible with hyper-experimental disciplines such chemistry. And that's why he asserts that the concepts of law do not fit with modern chemistry. In this sense, he tried to propose to remove the notion of law and to replace it by the notion of models, and that's he proposed. Then we can find some kind of eliminativism from a monist point of view. For example, Nancy Corrett said like chemical law, not chemical law, but chemical law and physical law is the same type, but this homogeneity does not occur because both of them are authentic law, but because neither are authentic law. In this sense, he says, if it's a good reason, then it must be physics, which is in the second-rate science. Not only do the law of physics have exceptions, unlike biological law, they are not even true for the most part, or approximately true. Okay, what's about the second strategy that asserts that they are chemical law, but they are the different type than physical law? Perhaps the most the great exponent of this position is Christie. Christie asserts that the task of philosophy is to try to describe the real practice of science, and if we try to describe the real practice of science, we can find that there is different kinds of law: universal law, local law, formal law, approximate law, and even some kind of law, like, as she said, Dalton law, that not have an precise formulation. And that's why he said for that the philosophy of science should try to describe this plurality and accept this plurality. On the other side, Scerri try to establish some distinguish between exact law and approximate law. And he assumed that the periodic law, he worked with periodic law, should be interpreted as an approximate law. By approximate law or by approximation, he understands two things. The first one, that the prediction that we can obtain from the kind of term are not from deductive algorithm, but rather for some kind of experimental intuition. And the second acception of the approximation is that, for example, the periodic law, when it was arranged from the atomic weight, have a series of contract samples. And in this sense, he asserts, for example, that perhaps chemical law should not be judged to be deficient by the standard of law of physics. Yeah, I'm glad to hear. I'm glad to hear you that maybe you are more interested in law of models. That for me, that's the right explanation about that. But I think that, and I agree too, that chemical law should not be should to be different, deficient. But I think that maybe it should not be deficient because there's no difference between both. And Theobald, into the same line, the last exponent of this second strategy that asserts some kind of pluralism of the notion of law, assert that due to the fact that the fundamental of chemistry are different from the fundamental of physics, and due to the fact that the chemistry use different concepts as molecules, substance, and structural molecular, and so on, we should not expect that we should be one and a single criterion of law. And in this sense, he said the behavior of collection of individuals is not predictable from the behavior of the individuals comprising those collections. Sorry, there are indeed real difference here. What conclusive argument is that there is not such a difference between the behavior of atoms and the electrons and the behavior of those collections of atoms and electrons we call molecules. In this sense, he has said that due to the fact that the concepts are members of different class, hence different class of law should be accepted. Okay, what can I say quickly about these two options in order to introduce what I want to say? The first one, that I said that in some sense there's no chemical law, for me is simply wrong. I not have nothing to do about that. Because there are chemical law, and I think that the task is trying to explain why some statement of chemical law function as scientific law. And the second one, that I said that there are chemical law and there are different types than physical law. I think that it's partially wrong, but for another reason, because they are not explanatory at all. I think that, and maybe Christie is the more clear example of that, when he said that we should only try to describe what scientific do and accept the pluralities, but describe what scientific do and accept that plurality does not suppose an explanation why some statements could be as scientific law. So in order to introduce my proposal, that I call it like monism. It's not my, but okay. In monism inspired from chemistry, I will try to flip the criteria, because I think that maybe to understand scientific law, we should pay more attention than chemical law than physical law. That's it. Flip the criteria, because we will understand scientific law through chemical law. But in order to achieve this goal, maybe two inputs are required. The first one, that was mentioned for Scerri too, is the monistic conception of science, according to which scientific law applies, that does not apply directly to real systems, but to ideal systems. And the second one, and distinguish between approximation and idealization, that was given by Norton. According to Norton, okay, an approximation is an inexact description of the real systems, while an idealization is not a description but a new system. Okay, in order to see how these two inputs could would be useful to explain what I want to say. Maybe one example could be illustrative to show the similarities between physical and chemical law. When in physics they try to explain an object falling into in the medium with resistance, they use this equation, and this equation they know that this equation is an approximation because it is an inaccurate descriptions about the real systems. But this equation that is inaccurate description of the real system is true, and exactly exactly descriptions of the ideal system, an accurate description of the ideal systems. In this sense, in Norton's term, we can say that the ideal system to which the law applied has certain properties that allows to represent, as all models do, in an accurate way, the real systems. And the same goes with chemistry. When we have gustita that it's an impure substance and does not apparently respect the Proust's law because the elements are not fixed in the same ratio, and that's why this formula, as it was mentioned, have the x where designated degree of deviations. The chemists use this ideal formula that are only an inaccurate descriptions of the real systems, but this formula is also true, an accurate description of the pure substance that is an ideal system. In this sense, from the molecular point of view, we can say that the properties that the model have, due to the fact that the law applies in the exact way to the ideal system, can infer some properties with respect to the real system that, of course, that are approximate about the real systems. The point, I think, to conclude is that the modelistic conception of science does, maybe against Schummer, I don't know if against or not about Scerri, does not exclude the notion of law, but it rather contain and explain why chemical law or the law are universal. In this sense, to conclude, we can say by understanding that the universal character of the scientific law are based on the intended models, and it is important, but what does it mean that the law are universal? And maybe it could be that they are applied in an exact way to the intended models of the theory, and recognizing that they apply not to the real system, but to the ideal system, we can understand that there is nothing weird with chemical law. That's it.
Okay, thank you, Hernan. So we have still time for questions. Anyone? Maybe someone in the chat that want to participate. It looks like, yeah.
Okay. Yeah.
Yeah, they are here, but no.
So if the laws are really the basis for a model rather than out there in the world, as it were.
Rather than? I'm sorry?
Okay. So your conception of law is that it's there as the basis for a model, right? Which is a sort of theoretical construct that we make in a laboratory.
Okay.
Okay. Then what is the model modeling? Is it modeling? I mean,
Yeah.
what would you say? I mean, so
About that.
I'm wondering what words you would use. Would you
Yeah.
say that it's modeling reality, or is it just so? What role does a model play now?
What role the model play?
Yeah.
First, I understand the questions, and I say something that because maybe it's appeared that I say that the model is like the models are based on the law. I'm not pretty sure that I'm saying that. I only try to say that the law applies to the models, but I don't think that the models are reduced to the law. It's not that the law determine all the kind of model, because precisely the modelistic concept of science assumes some kind of autonomous of the model of the theory, and maybe this presentation seems to go against the modelistic conception of science, according to which the models are autonomous agents of the law or of the theory. Yeah, I'm not saying that, but I think that the law applies to the models, and maybe the difference is if some models could be autonomous of specific law of a specific theory, and I am agree that the model could be that not depend of a theory, but needs some law in order to explain the dynamics of the elements of the models. And the point is that perhaps one of the main characters of the model is to represent the systems through maybe the dynamics imposed by some law that belongs to some theory. That's my point of view. But that's I want to say. I don't know if. Yeah. I try to say that the models that don't depend. When I say that they are autonomous, they don't depend of the law, because it's not exclusive about the law. Yeah. Yeah, that's I want.
Okay, someone else with 5 minutes, if not.